September 18th, 1884, 6:47 a.m. Thomas Whitworth's hand hovers over the valve, steam pressure 50 pounds per square inch. 14 men watch in silence. Nottingham's future rests on what happens in the next 60 seconds. The city is dying of thirst, not poetic thirst, the kind that kills. Cholera, typhoid, riding into homes on every drop pulled from the River Trent. 180,000 people. Water supply designed for half that. The mathematics are brutal. More people, same water, more death. Dr. Edward Seton tried getting answers in 1873. How much water does Nottingham have? The private waterworks company refused to tell him. Trade secrets. Children died while men protected profits. But in 1879, Nottingham Corporation bought the waterworks, made it public, put Marriott Ogle Tarbutton in charge, 59 years old, surveyor, engineer, builder of gasworks and sewers across England. He reviewed the records for 3 months. His conclusion, Nottingham would run out of clean water within 5 years. Tarbutton went north. 8 miles from the city's smoke, he found Papplewick. Forest, silence, and underneath, Bunter sandstone, 300 million years old, holding millions of gallons of pure groundwater naturally filtered through ancient geology. He sank a test well in 1882, 190 feet down. The result exceeded expectations, 1.3 million gallons per day. Immediately, he ordered 2 permanent wells, 202 feet deep, connected by horizontal shafts 271 feet long. Capacity, 3 million gallons daily. But wells need engines, machines that run constantly, reliably, forever, never break down, never stop. Tarbutton chose James Watt and Company. The name carried weight. Watt perfected the steam engine, his parallel motion linkage, his separate condenser, revolutionary. By 1884, his company had built beam engines for over a century. They knew what lasted. The contract, twin engines, cylinders 46 inches diameter, stroke 7.5 feet, beams 25 feet long, 13 tons each, flywheels 20 feet across, 24 tons each, every component machined to thousandths of an inch, every bearing hand fitted, every surface polished to reflection. But Tarbutton wanted more than machinery. He designed a Gothic cathedral, red brick with terracotta flourishes, stained glass depicting water cycle, cast iron columns decorated with brass ibises and fish, cooling pond like a formal garden, chimney 120 feet tall, rising like a church tower. Critics asked, why spend money on decoration nobody would see? Workers would operate it. Who were they decorating for? Tarbutton's answer, the water is clean. The building should reflect that. Purity deserves beauty. Civic responsibility deserves pride. Construction took 3 years. Horse carts hauling materials down muddy tracks. No electricity, no phones, just men, animals, and steam cranes. By September 1884, everything was ready except one detail. Nobody had started both engines simultaneously. Whitworth stands ready. Chief engineer, 52 years old, trained under Tarbutton, 30 years making public works work. Now holding 180,000 futures in a swan neck valve handle. 6 Lancashire boilers feed the system, each 29 feet long, 7 feet diameter, holding 3,200 gallons. 2 fireboxes per boiler, 32 cross tubes maximizing heat transfer. Whitworth opens the valve. Steam floods the cylinder. The piston rod rises, 5 inches thick, polished steel. The parallel motion linkage converts linear to circular. The beam tilts. 13 tons moving like a dancer. The flywheel turns once, twice, building momentum, finding rhythm. 8 strokes per minute, 140 horsepower. The pump rod drops 200 feet. Starts pulling water, 1,500 gallons per minute. 25 gallons every second, up from sandstone through cast iron pipes, out to the city. Engine 1 runs 6 weeks alone. Engineers monitor everything. Then November, Engine 2 starts. Both machines running parallel. 3 million gallons daily. 20 gallons per person. Clean, pure, constant. Disease rates drop. Infant mortality falls. Public fountains flow. The city's first public baths open. Industries expand. And the engines never stop. 24 hours, 7 days, 52 weeks, year after year. Shift changes happen while machines run. Maintenance happens while machines run. The system designed with redundancy that nothing requires complete shutdown. Stokers develop rhythm. Each shift burns tons of coal from Linby Colliery, shoveled by hand. The art, reading steam pressure, too little, engine slow, too much, danger. Or good stokers sense exactly when to add another shovel by listening to the boiler breathe. Tenters watch engines like sleeping children every 8 minutes. Circuit check, bearing temperatures by touch. Listen for unusual sounds. Watch for vibration changes. Apply grease, apply oil. No sensors, no alarms. Human attention is the monitoring system. Years pass. Staff ages together, retires, trains replacements. 3 generations in the superintendent's house are learning the station's rhythms from birth. Technology advances. Electric motors replace steam. Diesel generators become standard, but Papplewick keeps running Victorian beam engines because they work. Because replacing something that never breaks makes no economic sense. 1906, underground reservoir cracks from mining subsidence, abandoned, engines keep running. 1922, electricity arrives, they install lights, engines keep running. World War I, World War II, rationing, bombings, engines keep running. By 1960, beam engines are considered obsolete, museum pieces. Papplewick's engines are 76 years old, but they show no signs of stopping. Bearings smooth, pistons perfect, linkages silent. 1969, economics intervenes. Not failure, economics. Electric pumps cost less, use less fuel, require fewer staff. Install electric pumps, keep steam engines on standby. 4 years silent, but maintained, oiled. Turned monthly to prevent seizing. Then 1973, standby, unnecessary. Modern pumps, reliable enough. Steam, era finished. Papplewick retires having pumped water for 31,000 consecutive days. 85 years without missing one single day. Without ever failing to deliver 3 million gallons when Nottingham needed it. But retirement means decay. Windows break, roofs leak, machinery rusts. Within 5 years, another industrial ruin. Except volunteers refused. Formed the Papplewick Pumping Station Trust in 1974. Negotiated lease. Opened as museum. Then someone suggested, run the engines again, just for demonstration. They found one serviceable boiler, cleaned the cooling pond, repacked glands, cleared oil ways. September 20th, 1975, 91 years after first startup. John Thorlby, last superintendent, returned, demonstrated the procedure, boiler lit, Steam built, valve opened, piston rose, beam tilted, flywheel turned. The engine ran perfectly. Today, 8 weekends yearly, volunteers fire boilers, raise steam, start both engines. Visitors watch 13-ton beams rise and fall with Swiss precision. Children feel the flywheel's vibration. Engineers study the linkages. Photographers capture light through stained glass onto brass. Original electric pumps still operate nearby, still supply 8,200 families. Wells drilled in 1882 still produce clean water through Bunter sandstone. Infrastructure designed 142 years ago still functions. But the twin beam engines run for different purpose now, not to pump water, to pump inspiration, reminding us humans once built things meant to last centuries, not quarters. That reliability wasn't a selling point, but basic requirement. That beauty and function weren't opposites, but partners. On steam days, both engines synchronized. The building fills with sounds Nottingham hasn't heard in 50 years. Deep breathing of steam, precise clicking of valves, smooth rotation of flywheels weighing tons but turning quiet as thoughts. Marriott Ogle Tarbutton died in 1887, 3 years after Papplewick opened. Never saw his engines run for decades. Never knew they'd operate flawlessly for 85 years. Never imagined they'd still run, still teach, still inspire in the 21st century. But he built them anyway, built them to last, built them beautifully, built them right. That's Papplewick's lesson. Not about steam engines or water pumps, about us, about what we're capable when we decide what we build matters, when we choose permanence over expedience, when we refuse to accept that failure is inevitable. 3 million gallons every single day, 85 years, never missed once. What are we building today that will still work in 2109?